was developed by mathematicians to describe distance. And the notation that we use looks kind of like this. We use a vertical bar and another vertical bar, and we'll place a number inside the vertical bars. Alright, so this would be read the absolute value of -3. Now what does that mean? It means how far is -3 from 0. Well, as we know, distance is always positive. So we're just counting jumps here. That's 3 jumps away from 0. It doesn't matter that it's to the left. So its absolute value is 3. Now, the absolute value of +3, well, +3 is right here, to the right of 0, and it is also 3 jumps away from 0. So it has the same absolute value. Alright, so what would the absolute value of 0 be? Well, how far is 0 from 0? It's no jumps at all. Okay? Now remember, 0 is not a positive nor is it a negative number. So we can't say that absolute value always turns out to be positive because 0 itself is a special case and it is neutral. But we can say that absolute value will always be non-negative. There's another format here as well. If you see capital A, capital B, capital S, and then a set of parentheses with a number inside of the parentheses, this is computer code for the absolute value function. Alright, so what's the absolute value of -5 2/10? Well, +5 2/10. That's how many jumps away from 0 you would be if you were sitting at -5.2. Alright, what about the absolute value of a fraction? The absolute value of 4/5 is 4/5. Okay? Alright, let's go ahead and subtract two absolute values. What about the absolute value of -1 minus the absolute value of -6? That would be equivalent to 1 take away 6. In this case, we would get -5. Alright, well, what if we put these two inside one set of absolute value bars? What if we had -1 minus a -6? Okay, -1 minus a -6 inside of one set of absolute value bars would turn out to be -1 plus a +6, which is equal to 5. The absolute value of 5 is 5. So look, this value was -5, this value was +5. So you have to kind of be careful about how it's laid out. Let's look at the graph of y equals the absolute value of x. It's kind of funky. It might surprise you what it looks like. Okay. If I put a -4 in here for x, y would be equal to the absolute value of -4, which would be +4. Absolute value of -3 would be +3. Absolute value of -2 would be 2. And here we would get 1. Absolute value of 0 would be 0. Absolute value of 1 would be 1. Of 2 would be 2. Of 3 would be 3. And of 4 would be 4. The picture for this is kind of interesting. Let's take a look. The absolute value of what number or numbers is 3. Okay? So, in other words, if our y is 3, what possible x values might have generated that? Well, let's go up and take a look once again at the graph. Okay, 1, 2, 3. Right here is y equals 3. It's the horizontal line that passes through y equals 3, right there. Okay, so that is intersecting the graph in two different spots, at x equals 3 or negative 3 and x equals positive 3. So it turns out that indeed there are two values that would generate an absolute value of positive 3, and they are negative 3 or positive 3. Okay, so the absolute value of x equals 5. What two values would generate that? Negative 5 and positive 5. Okay?
Yo, it's Math Mix-Up. Everybody loves Math. Gotta love the teacher. You happy?